Preferred Utilities Manufacturing Corporation. Burner Management Systems. A technical discussion. Preferred Utilities Manufacturing Corporation. Introduction. Burner Management System Objectives. BMS Design Standards and Definitions. BMS Logic. BMS Strategies and Hardware. Types of burner management systems. BMS interface to SCADA systems. Summary. Introduction. Burner management systems. A starting point. Introduction. What is a BMS? A burner management system is defined as the following. A control system that is dedicated to boiler safety, operator assistance in the starting and stopping of fuel preparation and burning equipment, and the prevention of misoperation of and damage to fuel preparation and fuel burning equipment. 1. From NFPA 8501 Standard for Single Burner Boiler Operation, Burner Management Objectives. Sequence burner through safe startup. Ensure a complete pre-purge of boiler. Supervise safety limits during operation. Supervise the flame presence during operation. Sequence a safe shutdown at end of cycle. Integrate with combustion control system for proper fuel and air flows. BMS Design Standards. Each burner management system should be designed in accordance with the below-listed guidelines to control and monitor all sequences of the startup and shutdown of the burner. National Fire Protection Association, NFPA 8501/8502 or others. Industrial Risk Insurers, IRI. Factory Mutual Loss Prevention Guidelines. Each burner management system should be designed to accomplish a safety shutdown in the event of an unsafe condition. Fail-safe. BMS Design Standards. U.S. National Fire Protection Association, NFPA. Governs safety system design on virtually all boilers, regardless of the process to be used to combust the fuel. Requires the separation of the burner management system from any other control system. Requires the use of a hardwired backup tripping scheme for microprocessor-based systems. Requires that a single failure not prevent an appropriate shutdown. Factory Mutual Loss Prevention Guidelines. NFPA 8501, NFPA 8501 Standard for Single Burner Boiler Operation. Single burner boilers with fuel input greater than 12.5 mT/HR, approximately 250 bhp. Single fuel or combination of fuels, common being natural gas, number 2 oil, number 6 oil. Simultaneous firing. NFPA 8502. NFPA 8502 Standard for Prevention of Furnace Explosions, Implosions in Multiple Burner Boilers. Multiple burner boilers with fuel input greater than 12.5 mT/HR. Single fuel or combination of fuels including pulverized coal. Emphasis on implosion protection, larger boilers with induced draft systems. BMS definitions. Furnace explosions. Ignition of accumulated combustible mixture within the confined space of a furnace or associated boiler passes, ducts, and fans that convey gases of combustion to the stack 1. Magnitude and intensity of explosion depends on relative quantity of combustibles and the proportion of air at the time of ignition. 1. From NFPA 8502 Prevention of Furnace Explosions, Implosions in Multiple Burner Boilers. BMS definitions. Furnace explosions can occur with any or a combination of the following: 1. Momentary loss of flame followed by delayed reignition. Fuel leakage into an idle furnace ignited by source of ignition, such as a welding spark. Repeated light-off attempts without proper purging. Loss of flame on one burner while others are in operation. Complete furnace flame out followed by an attempt to light a burner. 1. From NFPA 8502 Prevention of Furnace Explosions, Implosions in Multiple Burner Boilers. BMS definitions: furnace implosions. More common in large utility boilers. Caused by any of the following: malfunction of equipment regulating boiler gas flow resulting in furnace exposure to excessive induced draft fan head capability. Rapid decay for furnace gas temperature and pressure due to furnace trip. 1. From NFPA 8502 Prevention of furnace explosions, implosions in multiple burner boilers. BMS Basic Definitions. Common terminology. Supervised manual. Manual burner light off with interlocks. Automatic recycling, single burner only. Automatic burner start and stop based on preset operating range, drum pressure. Automatic non-recycling, single burner only. Automatic burner start and stop based on manual command to start. Types of flame scanners. Infrared, IR, detectors. Single burner applications. More suitable with oil burning flames. Ultraviolet, UV, detectors. Multiple burner applications. More suitable for gas burners and combination gas, oil burners. Self-check scanners. Flame signal is interrupted at set intervals to verify proper operation of scanner. Single burner BMS inputs. BMS logic. Burner management systems can be broken down into interlock groups. Typical BMS interlock groups. Boiler purge. Igniter header valve management. Main fuel header valve management. MFT, master fuel trip, logic. Purge interlocks. Igniter interlocks. Main flame interlocks. Single burner main fuel trip. BMS system types. Early burner management systems. Hardwired systems. Solid-state systems. Microprocessor-based systems. Fire IE110, Honeywell 7800 series with fixed logic. PLC-based systems. Programmable logic controller, PLC-based. Powerful, versatile, expandable, more reliable. Early burner management systems. Hardwired systems. Relay and timer driven. Found on older installations. Typical of late 50s, 60s. Solid-state systems. Solid-state processors and relays. Found on systems provided in the 70s and 80s. Proprietary hardware, Forney and Peabody. Spare parts are extremely hard to find. Microprocessor-based systems. Microprocessor-based system providing burner sequencing, ignition, flame monitoring, fixed program with limited configuration changes, components selected based on requirements, programmers, flame amplifiers, message displays, Fire IBMS layout. Microprocessor capabilities. Simple, cost-effective. Features. Selectable flame amplifiers, scanners. Remote display. Remote data communications via Modbus port. Modernization kits are available to integrate with older systems. Spare parts normally readily available when these systems are used. Simple boiler installations. Packaged fire tube, water tube boilers, steam, hot water. Single burner. One fuel at a time. No flue gas recirculation. Upgrades from previous microprocessor-based systems, PLC-based burner management systems. PLC-based features. NFPA 8501, 8502. Watchdog timer. L508 certification. Redundant scanners. Logic Plus Message Center. Shows program status. Displays alarms. Prompts operator. Custom enclosure shown. The annunciator information is also shown on the message center. Optional indications and push buttons are shown. PLC system basic design features. Each PLC-based burner management system should incorporate a number of design techniques which help detect and act upon unsafe failure modes which can occur in any microprocessor-based system. These design features include the following: critical input checking, critical output channel monitoring, electromechanical master fuel trip (MFT) relay, redundant watchdog timers, low water cutout monitoring during blowdown. PLC-based system capabilities. Provision for multiple fuel firing. Capped gas input during curtailment. Changeover from gas to oil at any load. Simultaneous firing of waste and fossil fuels. Redundant scanners, change scanner with fuel. Single or multiple burner applications. Integration of BMS with SCADA. PLC-based operator interfaces. Features. Clear written messages to indicate status, required operator interaction, trip/alarm indication. High visibility through 2 lines of display. Messages reduce time-consuming troubleshooting. Prioritizes messages. First out alarms. Warning, alarm messages. Status messages, prompts operator. PLC system layout, typical. Benefits of PLC-based systems. Flexibility, reliability. Programming software allows changes to system. Choice of PLCs. GE, Modican, Allen Bradley, Koyu. Choice of flame scanners. PPC, FireEye, Honeywell, Iris, Cohen. Application-specific. Quantity of burners, fuels is not restricted, when to use PLC-based systems. Complex boiler installations. Larger packaged units, field-erected units. Multiple burners. Multiple fuels, online fuel changeovers. Flue gas recirculation. Replace existing relay logic systems. Requirement to maintain consistent control platform, spare parts, etc. BMS SCADA interface. BMS systems can be integrated into a SCADA system. Allows remote monitoring of flame status. Allows remote control of BMS. Events, burner trip, can be routed to historical portion of SCADA for fault evaluation. Burner operation can be trended over time. BMS SCADA interface. Interface methods. BMS SCADA interface. Summary of benefits associated with new burner management systems. Help improve plant safety. Help qualify for reduced insurance cost. Reduce startup and downtime with comprehensive alarming and diagnostics. Summary review of topics discussed. Objectives of burner management systems. BMS design considerations. Basic BMS logic. Types of burner management systems. How BMS systems can be integrated with plant-wide SCADA systems.